Hello students, today we will see the theory part 15 of the chapter 8 Organic Chemistry, some basic principle and technique, in which we will cover the NCERT section 8.10. So this is our disclaimer. Now once you have attended this lecture, you will be able to understand the principle involved in the quantitative analysis of the organic compound. So we have already started with this thing. So we will continue with this thing with the remaining elements, I would say. Now, if I talk about the specific sections of the NCERT, then we would be covering the 8.10, which is quantitative analysis, in which we will cover it for the sulfur. So it is 8.10.4. So we have covered it for carbon and hydrogen, for nitrogen, and for the halogens. Our today's objective would be for the sulfur. Then we will look for the quantitative analysis for the phosphorus, which is NCERT section 8.10.4, 8.10.5. Okay. Then lastly, we have it for oxygen, which is 8.10.6, which is detection of oxygen through quantitative methods. Starting with the sulfur estimation. So we will start with the Carius method for the sulfur estimation in organic compounds. Now let's look at the principle of this method. Sulfur in organic compound is oxidized to the sulfuric acid, which is then precipitated and weighed as barium sulfate. So this process allows us to determine the amount of sulfur present in a given amount of organic compound. Moving on to the oxidation step, the organic compound is heated in a Carius tube. So this is a special type of glass tube used to safely conduct reaction at high temperature and pressure. In this step, we see that sodium peroxide, sodium peroxide or fuming nitric acid are used as oxidizing agents, and this chemicals help convert this sulfur into the sulfuric acid. Now, what is the formula for sulfuric acid? Of course, it will be H2SO4. After that, what we do? We have the precipitation step. Excess barium chloride solution is added to the sulfuric acid to precipitate off the barium sulfate. So this is a common method to isolate the sulfate ions. Now, in this chemical reaction, sulfuric acid reacts with barium chloride to produce barium sulfate and hydrochloric acid. Now, barium sulfate is insoluble. It will be forming a solid precipitate. Next, now let us discuss the isolation of the precipitate. So, the barium sulfate precipitate is separated from the solution. How it is separated? The first step is isolating the precipitate is filtering it. So this is the first step of filtration. Then after filtering, the precipitate is washed. This ensures that any impurities or excess reagents are removed from the barium sulfate. Next, once washed, the precipitate is dried. This step removes any remaining moisture, ensuring accurate weighing. Lastly, we weight this dried precipitate. So this weight allows us to calculate the amount of sulfur originally present in the organic compound. So these are some steps to do the I would say sulfur estimation. Now let us look up on its detailing. Moving on further, next we have the calculation part. Now we are trying to calculate the percentage of sulfur in a compound. So this involves the using the mass of barium sulfate, which is formed during the process. Now here we focus on the percentage of sulfur determined from the mass of BaSO4. This means that by measuring the amount of barium sulfate produced, we can calculate how much sulfur was present in the original compound. We now see the molar mass information. So 1 mole of barium sulfate, which weighs 233 gram, contains 32 gram of the sulfur. Then after, the formula for calculating the percentage of sulfur is now visible. So which is 32 upon 233 multiplied by M1, upon M into 100. So this is the overall formula. What is your M? So M is defined here as the mass of the organic compound which you have taken. So this is the starting material whose sulfur content we are trying to determine. Then after we have M1, which is defined as the mass of BaSO4 formed. So this is the product of the reaction that we measured to find out how much sulfur was in the original compound. Next, we move on to the phosphorus estimation in organic compound. So now we see the principle behind the phosphorus estimation. So phosphorus in organic compound is oxidized to form phosphoric acid. So this phosphoric acid is then quantified either as ammonium phosphomolybdate or magnesium pyrophosphate. So this process helps us to measure the amount of phosphorus present. Then after, we are introduced to the first method of the phosphorus estimation, which involves forming ammonium phosphomolybdate. So this compound is represented by the molecular formula NH4 whole thrice PO4 dot 2L MO, which is molybdate O3. So this method is one way to quantify the phosphorus content. The next one is what? So the next one is the magnesium pyrophosphate. So we'll look upon it later. So moving on to the method number 1. First method is, the first step is oxidation. How do we oxidize it? So the organic compound is heated with fuming nitric acid, which is HNO3. Now your HNO3 is a strong oxidizing agent that helps in breaking the compound to release phosphorus, which will be then converted to the phosphoric acid, which is H3PO4. Now we move on to the precipitation step. Here the phosphoric acid is precipitated as ammonium phosphomolybdate. So this is done by adding ammonia and ammonium molybdate to the solution. So this step helps us in isolating the phosphorus for measurement. So this was for the method number 1. Now if we see the calculational part, how do we do it? The first step in our calculation involves the mass of the organic compound is taken, which is m grams. Now we have the mass of the ammonium phosphomolybdate, which is denoted as m1 gram. So this compound is formed during the estimation process and is crucial for determining your phosphorus content. Next, we now see the molar mass of ammonium phosphomolybdate, which is 1877 grams. So this value is the molar mass of the ammonium phosphomolybdate. Next, finally, we have the formula for calculating the percentage of phosphorus in the sample. It involves multiplying 31 by the mass of ammonium phosphomolybdate, then dividing by the product of its molar mass and the mass of the organic compound, and multiplying this whole thing by 100 is helping us to get the percentage part. So this formula allows us to quantify the phosphorus content accurately. Moving on further, now we are moving on to the method number 2 for phosphorus estimation. Here, what we do in the method number 2, it involves the formation of magnesium pyrophosphate, which is Mg2P2O7. So this method is commonly used in laboratories for accurate measurement of phosphorus content. The first step again is oxidation. How do we oxidize it? Similar to the previous one, we use the fuming nitric acid, which is HNO3, to convert your phosphorus into phosphoric acid. So phosphoric acid is H3PO4. As you all know, your HNO3 here is acting as a strong oxidizing agent. Next is the precipitation step. So this involves the conversion of phosphoric acid into a precipitable form. Phosphoric acid is precipitated by how? By adding magnesium ammonium phosphate. Okay, sorry, magnesium mixture. Okay, so it is precipitated as magnesium ammonium phosphate. So this step is essential for isolating phosphorus in a measurable amount. Then after, next is ignition. So magnesium ammonium phosphate is ignited to yield magnesium pyrophosphate, which is Mg2P2O7. So this transformation is the key to determine the phosphorus content accurately. The chemical reaction for this process is shown here. So the 2MgNH4PO4 is converted to Mg2P2O7, releasing ammonia and water. So this reaction highlights the conversion of precipitate into desired pyrophosphate form. Now moving on further, now we will see the calculation part. Okay, so this involves using the formula to calculate the phosphorus content. How do we do it? We already know that the molar mass of magnesium pyrophosphate is 222 grams. Then The formula for calculating the percentage of phosphorus is here. So it involves dividing the mass of phosphorus in magnesium pyrophosphate by the molar mass of magnesium pyrophosphate, then multiplying the mass of the magnesium pyrophosphate over the mass of the organic compound and multiplying this whole thing by 100 to give us the percentage form. So this formula helps us quantify the phosphorus content in a given sample. So we have dealt with this phosphorus estimation. Now we are going to discuss method for estimating oxygen in organic compound. So now let us look at the indirect estimation method first of all. So this involves calculating the percentage of oxygen by subtracting the percentage of other elements from 100%. Okay, so it's a straightforward way to determine the oxygen content when other elements are known, when the percentage of other elements are known. So this is the indirect estimation. Moving on to the direct estimation. So this is a bit hand-on approach to determine the oxygen content in an organic compound. In the direct estimation method, the first step is decomposition. So here a known mass of the organic compound is heated in a stream of nitrogen gas. So this process releases oxygen gas and other gaseous products. Then after, next the gaseous mixture is passed over red hot coke at high temperature of 1373 Kelvin. So this converts all the oxygen into carbon dioxide, represented by the equation 5a. Finally, the carbon monoxide mixture is passed through warm iodine pentoxide. So this converts the carbon monoxide into carbon dioxide. The iodine pentoxide acts like a catalyst, facilitating the conversion. So this step is crucial for accurately measuring your oxygen content. Next, now we see two chemical equations. The first equation shows carbon reacting with oxygen to form carbon monoxide. The second equation involves the iodine pentoxide reacting with this carbon monoxide to produce iodine and carbon dioxide. Now these reactions are important for understanding how oxygen is consumed and transformed in the following chemical processes. Here we are multiplying the equation, the first equation by 5, okay, and the second equation by 2. This step is crucial for balancing the equation and ensuring that the number of atoms for each element is same on both sides of the reaction. So this is a key part of the stoichiometry which helps us understand the proportion of reactants and products. From the combined reaction, we see that 1 mole of oxygen from the compound results in production of 2 moles of carbon dioxide. This means that 32 grams of oxygen is equivalent to 88 grams of carbon dioxide. Next, we have the calculational part. Let's say the mass of the organic compound is taken as m grams. Next, the mass of carbon dioxide produced is m1 grams. So m1 gram of carbon dioxide is obtained from 32 into m1 by 88 gram of oxygen. So specifically, m1 gram of carbon dioxide is obtained from a certain amount of oxygen calculated as 32 times m1 divided by 88 grams of oxygen. Next, finally we calculate the percentage of oxygen in the compound. So this is done by using the formula 32 times m1 times 100 divided by 88 times m. So this formula helps us to express the oxygen content as a percentage of the total mass of the compound. Here we have a question. Okay, so on complete combustion of 0.246 gram of an organic compound, it gives us 0.198 gram of carbon dioxide and 0.1014 gram of oxygen. Water. Determine the percentage composition of carbon and hydrogen in the compound. So how we'll do it? So what are the things that are already given? Say we have the mass of the compound denoted as m naught grams and it is equals to 0.246 grams. So it is already given in the question, okay, right? So no confusion in this. Then next we have the mass of H2O, which is 0.1014 gram. Here we are denoting it as M1. After that, we have this M2, which is the mass of carbon dioxide and it is given as 0.198 gram. How do we calculate the percentage of hydrogen? It's very simple. So 2 by 18 multiplied by M1 by M0 into 100. What about the percentage of carbon? So 12 by 44 into M2 by M0 into 100. So this is used to measure the percentage of carbon. If I talk about the percentage of hydrogen, so we apply the formula by substituting the values into the above formula, so resulting in 4.58% of hydrogen. Similarly, if we substitute the formula in the formula for the second part, we will get the percentage of carbon as 21.95 grams. So this was our first question. Next one, in sulfur estimation of 0.157 gram of an organic compound, it gives us 0.4813 gram of barium sulfate. Now, what is the percentage of sulfur in the compound? You have to determine that. So, moving on with the solution, we first of all start with the things that are already given in the question. So, we are given with the mass of organic compound, which is 0.157 grams. Then we have the mass of barium sulfate, which is 0.4813 grams. After that, we can calculate the molar mass of barium sulfate, which will be the molar mass of barium 137 plus the molar mass of sulfur, which is 32, and 4 times the molar mass of oxygen, which is 64. If you add it, you will get it as 233 gram per mole. Next, the atomic mass of sulfur is already known. It is 32 gram per mole. This value will be used to calculate the mass of sulfur present in the barium sulfate. So, mass of sulfur in 0.4813 grams of barium sulfate is equals to, we use the unitary method here. So, 32 into 0.4813 divided by 233 gram is equals to 0.0661 grams. If we multiply this whole thing by 100, then we will get the percentage of sulfur in the organic compound as 42.10%. So, this is your final answer. I hope this is the easy one. Moving on to the next question. So, the question is related to the Carius method, where we have to find out the percentage of bromine in the compound. So, we are given with the amount of organic compound, which is 0.15 gram, and we are already given with the mass of the AgBr formed during the Carius method, which is 0.12 grams. Next, we write this given data. So, let us say the molar mass of AgBr is 188 gram per mole, we know it. Then the mass of AgBr formed will be 0.12 grams. After that, the mass of the substance, which is the organic compound, it will be 0.15 grams. So, how do we calculate it? So, from the mass of silver halide, the quantity of halogen in the sample is calculated. The formula that we already know is given here. So, the percentage of halogen is equals to atomic mass of bromine divided by the molar mass of the silver bromide. Then it is multiplied by mass of silver bromide formed divided by the mass of the compound, and this thing is multiplied by 100. If you put all the values, you will get it as the percentage of bromine 80 into 0.12 into 100 divided by 188 into 0.15. So, this will give you 34.04% of bromine. Let us summarize today's discussion. So, we started with the Carius method for sulfur estimation. So, the percentage of sulfur is equals to 32 by 233 into M1 by M into 100. Here, the M is the mass of organic compound and M1 is the mass of barium sulfate formed. Next, we talked about phosphorus estimation. So, in method 1, we have ammonium phosphomolybdate as the precipitate. So, it involves multiplying 31 by the mass of ammonium phosphomolybdate divided by the product of 1877 and the mass of the organic compound, then multiplying this whole thing by 100. Here, m gram is what it is the context for phosphorus estimation formula. So, it refers to the mass of the organic compound taken for analysis. Then we have m1 gram in the formula. So, this is the mass of the ammonium phosphomolybdate formed during the reaction. So, this compound, this is used to precipitate phosphorus for measurement. Talking about the method number 2, what do we do in this? So, we have magnesium pyrophosphate as the precipitate. So this method provides an alternative way to measure the phosphorus content. The formula for calculating the percentage of phosphorus using magnesium pyrophosphate is shown here. So it involves the ratio of the mass of phosphorus in magnesium to its magnesium pyrophosphate to its molar mass, multiplied by the ratio of the mass of the magnesium pyrophosphate to the mass of the organic compound, and then multiplying by 100. Next, we have oxygen estimation. Now we see the formula for calculating the percentage of oxygen in organic compound. The formula involves multiplying 32 by the mass of carbon dioxide produced, then dividing by 88 times the mass of organic compound, and finally multiplying it by 100 to get the percentage. So this formula is crucial for accurately determining the oxygen content. Here we have m grams, which is the mass of the organic compound. Then we have m1 gram, which is the mass of carbon dioxide produced. So this was all for today's lecture. Thank you for joining the session. I hope you enjoyed it.